So I just wanted to give a quick demonstration of the C compiler that I have been working on. So for my homebrew CPU, I decided that I wanted to write a C compiler for it because I had been programming in assembly. Well, I still am programming in assembly language for it. And as much as I like assembly language, it's a lot of work, especially for writing other things like operating systems and things like that. So I wrote the operating system for the CPU in pure assembly. So I thought I always wanted to write a C compiler, so I finally decided to just give it a try. So I basically adapted my old C interpreter that I had written previously. So I adapted that into a C compiler, and the compiler right now is compiling a good subset of C. Not everything, but some of the constructs of C, and well, the most important ones, they work already. So the only thing that I don't have, well, the only things that I don't have right now are proper types. For example, uh, I can declare integers and chars, for example, and pointers, also strings, but it doesn't work very well yet. I can't declare structs and constructs like that. So here's the code for the compiler. So far it's about 1.5 thousand lines. Um, and this is just a header file, and this is a test program. So this is an actual program that the compiler will compile. So this demonstrates most of the features that the compiler is able to understand. So I can do includes, which in this case is not including a header file, it's including an assembly language library. So I can declare the integer variables like this and initialize them, char and pointers to strings like that. And so I can declare various functions, and there is the main function here, and then I can do parsing expressions, etc. There's also this ASM assembly block here because for calling functions, for example system calls um, and other library functions in assembly, I still have to do it in assembly like this. Okay, so you can see there's a function here, and it parses while constructs, if else, else, etc. So all of this works, and so what it does, it takes the C program like this and generates an assembly file. So it compiles into assembly, and then I use an assembler to convert this into binary. And right now the C compiler is not optimized. It's inefficient. I will optimize it in the future. I actually don't have time to continue working on the compiler right now, so I will leave it for some time. Uh, so as you can see, it generates the assembly, and for example, here's the code generated for the while loop. So while the condition for the while, this is a label for the condition, and then the while block, and so here's the other while loop. So you can have nested whiles as well, and it will keep track of all the labels uh, like that. So this is the code generated for the program, the test program. As you can see, it generates also the data block like that. So here I can show you an example. So for example, if I want to compile, I have this little script here which will run the compiler and then the assembler. So if I run it like that, so it compiles the C program, and then it assembles after it generated the assembly language, it runs the assembler and generates the binary. And then I just made it so that it turns the binary into a hex string and copies that to the clipboard, so I can just go here on the prompt of the CPU, and I can for example make bin test to create a binary executable, and then I can paste the code directly here and then enter, and that will create the file. So as you can see there, we have the test file, so I can run it here like this. So in that case, that program is just a simple program to find some prime numbers. So if I run it, as you can see, it does run. So the C compiler works well. It just goes up to 499 here right now. So this is hardware. I have a few other programs which I was testing, like the Pascal generates a Pascal's triangle. So ask for the number of rows, let's say 20, and generates the Pascal's triangle there. I also have just a simple program to find the factors, another fact, the factors of the, not the prime factors, but all the divisors of the number. So it's just a test program. Here in this page, so this is the Pascal's triangle program. So this is the program here, and you can see, as you can see, there's some nesting going on here. So you have a for loop, and then opening blocks, and then you have another for loop inside of that, which just a simple function call, etc. So nesting works fine. So actually the compiler is quite good. Right now it compiles a lot of stuff, but it's not a complete C compiler yet. So I'll have to leave that to the future. Whenever I have some more time, I will work on that. So you can you're probably aware that you can telnet to the CPU here live. It's on most of the time. So if you just go on telnet and access it, you can play with the CPU here live. Also added an entry here on the website for the C compiler. You can click here and download a zip of the compiler, the source code, and the examples. So the root directory has the cc.c, which is the C compiler, etc. And then the bin has the executable, C compiler executable, and a few simple programs. It also has the assembler here, so you can just run the compile.sh program if you want to try doing that. So that's it for now. I just wanted to show you this little project. I had been wanting to write a C compiler for a long time, but I never got to really doing it. But after I designed and built the CPU, I thought it was very imperative to have a C compiler, so that was a good opportunity to start doing it. So that's it for now, and thank you for watching.